Greetings, mathematicians. Today we're looking at example 3a, solving quadratic equations by completing the square and applying the square root property. We are going to be following these rules from above here. However, if we look at 3a, it's already solved in the form of ax squared plus bx plus c equals 0. The a value, the coefficient for x squared, is already 1, so we can actually go straight into getting this ready to complete the square. So the way we're going to do that, first we need to have the variable terms on one side and the constant on the other. So we're going to do that by subtracting 13 from both sides. When we subtract 13 from both sides of the equation, on the left side we get x squared minus 6x, and I'm actually going to leave this space here where that 13 was. I'm going to leave space for completing the square in just a little bit, and then 0 minus 13, negative 13. Well, now I need to complete the square. So completing the square means I look for my b value, negative 6, I take half of that, and then I square it. So half of negative 6 is negative 3. Negative 3 squared, which is negative 3 times negative 3, is positive 9. Now, I just added 9 to this side of the equation. To balance the equation, I have to add 9 to the other side as well. But now what I have is a perfect square trinomial, and this is where that half of b comes in. Half of negative 6 is negative 3, so when I write the factored form, this is where my negative 3 shows up as a minus 3, x minus 3 squared. If I were to multiply this out, I would get this perfect square trinomial. And it's equal to negative 13 plus 9, which is negative 4. Right here at this step, I actually have the vertex for this quadratic. The vertex in this step right here, if I have the perfect square trinomial here and I have the constant here, the vertex is always going to be the opposite of this value, comma, or opposite of this value for x, and then comma, the opposite of this value for y. So my vertex for this quadratic is at 3, 4. That would be the vertex. But we're actually solving this for x values. So since we have the quantity squared, we want to solve for x. So we have to get rid of the square. And we do that by taking the square root of both sides. So I'm going to write x minus 3 in parentheses squared equals negative 4 again. But this time I'm taking the square root of both sides. The square root of x minus 3 in parentheses squared is x minus 3. The square root of negative 4 would be 2i, but because we're taking the square root of the number, we have to think about the positive root and the negative root. So it's plus or minus 2i. Now, x minus 3 does equal positive or negative 2i. However, before we split this into two answers, we are going to add 3 to both sides. So I'm going to add 3 to the left side of the equation, add 3 to the right side of the equation, and the left side is pretty normal, x minus 3 plus 3, that's just x. On this right side, I do have positive or negative 2i plus 3. Well, I could also say that with the term first. I could say that 3 goes first, so 3 plus or minus 2i. Now that the variable is by itself, now I can split this up into two answers. One of them is going to be with the plus sign, so 3 plus 2i. That's one of my solutions, imaginary solutions. And the other solution would be with the minus sign, 3 minus 2i. And that's how you use completing the square and applying square root property.